Hello everyone. I hope you all have heard about the mass action law in a transistor, that is the product of minority carriers into product of majority carriers. Let us call the minority carriers as N, majority carriers as P. So the product of both is equal to Ni square. Ni can be called as intrinsic density. So we all know that it is a law. Fine. Today what we are going to do is we are going to try to prove it. To prove that law we have to start with the potential developed in a transistor. So to talk about potential developed in a transistor, let me draw a PN junction. Now in this particular PN junction, since no voltage has been applied, let us look into only the P part. Since no voltage is being applied in here, so the net current density J should be equal to 0. Obviously the current has to be equal to 0 since no external voltage has been applied, and in that case the net current density will be 0 as well. So this will form the basis of our derivation. We will start with making the current density equal to 0. I hope you are well aware of the formulas for current density in a semiconductor. So in that case, let us proceed forward. Now let us consider only the p-type part. In this p-type part, I am taking 2 points p1 and p2. So I am going to write the equation for current density. The general equation for current density, in case the current is a drift current, will be N into Q into mu multiplied by electric field. So let me describe all the components. This N will be the charge density, we'll call it the number of carriers, say holes per meter cube. Q will be the charge on an electron, that will be a equal charge on the hole as well. Mu will be the mobility, and E will be the electric field. Now if some people do not understand how it came, let me dig a bit deeper into the derivation. If you all remember, I is equal to NEAVD. This is the general equation. I hope nearly all the engineers will remember. Vd will be the drift velocity, N will be the same thing, the number of holes per meter cube, this will be N. E means it is nothing but Q. A is the area, the cross-sectional area. Vd is the drift velocity, I told already. Now Vd will be what? The definition of mobility is drift velocity per unit electric field. In that way we can substitute Vd with mu into E. So in that case I will become nothing but N into Q into A into mu into E. Now J is nothing but I by A. In that way we get this particular derivation. I hope you people understood. Now let me clear everything the board. So we were here with the J. This will be the J due to drift current. Now let us talk about J due to the diffusion current. In case there is a difference in concentration in charges, there will be a current density which will be equal to J is equal to Q into dP by dx. dP by dx is the charge gradient. dP is a constant, Q is the charge on the electron. So in this case, conventionally, the diffusion current density of a p-type holes, basically it is considered as negative, so it will be minus Q dP by dx. If I sum of these two equations, what will I get? I'll get one equation that will say that J is equal to nothing but NQ into mu into E minus Q dP into dP by dx. Now since we are dealing with the positive type holes, I'll just substitute this N, this particular thing, with P. This is what the charge density of holes are. I'll replace it with P, because this particular P signifies the change in charge, is the change in concentration of hole. So, or to ascertain a similarity, we will just do it. So now J has to be equal to 0, making it equal to 0. I'll get N, which will be P now. PQ mu into E should be equal to Q dP into dP by dx. Now in that case, this Q and this Q gets cancelled, so I am left out with dP by dx is equal to P mu E by dP. I hope you people are understanding it for now. We'll now proceed to the next slide. Now, this was the equation we had previously derived. Now, moving a bit deeper into it, we have to again go with another law, which was another contribution by Einstein, which says that dP by mu P is equal to dN by mu N is equal to Vt. So, this particular part here, it can be replaced by Vt. So in that case, we would be left up with a rather simplified equation, which would say that dP by dx is nothing but Pe by Vt. Now this E is the electric field, which can be further replaced by minus dV by dx. So it will say that dP by dx is equal to minus P by Vt into dV by dx. It looks nothing but a normal integral equation. We just have to solve it now. So in that case, we'll just move forward to another simplified form. We should say that dP by P is equal to 1 by Vt minus actually into dV. Now if I integrate on both sides with limits v1 to v2, and this P equal to P1 to P2. Now P1 P2, we'll just go back to the previous slide to understand it. Just hold a minute. So in here we have, this is P1 and this is P2. I hope you understand. And the V21 will be the potential difference between these 2 points, V21. Understood? Let's move back. So in that case, I'll just integrate it within the limits. dP by P, P1 to P2 is equal to minus 1 by Vt dV integration V1 to V2. I hope you people are getting it. Simple mathematics, nothing more than that. So if I integrate it further, I'll just get ln P1 by P2 is equal to V2 by V1 is equal to V2. In that way, if I take the anti-logarithm, it will give me that P1 is equal to P2. Here I forgot the Vt. Vt part will always be there. So P2 e raised to the power V21 by Vt. I hope you people are understanding. So this will be one of the important equations which will be very useful in understanding transistor. It gives nothing but, if you know the concentration at a particular point, say this point, if you know the concentration, if you know the potential difference V21, you can calculate the concentration at this point. So this will be a very important equation for understanding transistor. Now if you do the same workout for the n-type material, for the electrons, we will get that N1 is equal to N2 e raised to the power, nothing but it will come out to be negative. So want to work out, you can work out again the same thing. Same things will be there, just in here in this part we have considered this negative, and this will go off and it will become positive, and hence the whole equation, the minus V21 part will be included. So now I have N1 P1 to P2. If I if I call it equation 1, if I call it equation 2, if I multiply both, I will get N1 into P1 is equal to N2 into P2. This is what is the basis of the mass action law. So now if I consider N2 is equal to P2 is equal to Ni, it will give me what? N1 P1 is equal to N square. This is what is called the mass action law. Thank you for watching. I hope it was educational and informative. If you like it, please comment, subscribe. See you again.